So, okay, good. Okay, thank you so much. Okay, so let's start. I just introduced myself and also Mr. Liu again, and you can see the email address of us. Actually, this PowerPoint has been uploaded to Moodle, so you don't need to copy anything at this moment, right? All right. So welcome again. Now, this term may be a little bit new to you, elevator engineering, because elevator is not a term commonly used in Hong Kong. Elevator is a term commonly used in North America, right? And also some part of the world. But in Hong Kong, we usually call lifts and escalators. Okay, lifts means vertical movement. Lifts, escalators, um, with a angle. Okay, it's landing. So I think for anyone living in Hong Kong are familiar with these two types of transportation devices in the buildings. All right. So in Europe, in Hong Kong, we usually call lifts and escalators. Um, and but generally speaking, elevator can include both lifts and escalators. So but I think our course will be mainly on lifts. Okay, mainly on lifts, and but I will introduce a little bit about escalators, not much. Now, a lot of laymen when they first be exposed to this term, elevator engineering, vertical transportation, drive, whatever, um, they may have a feeling that it is a very narrow, how to say, a very narrow topic, but actually it's not. Um, so although the title is on elevators, its coverage is broad. Okay, so let me mute everyone uh, so that oh, sorry. Let me see whether I can mute or how can I do it? I'll mute all here. Okay. Yeah. All right. So it involves electrical engineering, of course, motor drive, right? Motor drive, electrical engineering. Um, I can tell you that in buildings, elevators or lifts, escalators have used the most advanced motor drives. Okay, in buildings. What you can see in the electric vehicle nowadays, like the Tesla, their motors are not very advanced compared with systems. What Tesla is using was used years ago, decades ago in lift systems. All right, so you'll learn a little more on motor drive, right? Electrical engineering, electronic engineering. There are a lot of sensors, a lot of controllers in the lift systems. So all are electronic. Computer engineering, control. Okay, so the main purpose of lifts is to convey passengers. Okay, around the buildings. So how can you assign a lift to a particular core? We call it a core. If you are standing at a floor asking for services by a lift, it's called landing core. If you walk inside the lift car, the car means the cage that you ride. Okay, in the lift. Uh, then you make a call. It's called car call. So these two terms will often be used in our course. Okay, landing call and car call. Landing call means you make the call at the landing. So how to respond to such calls is computer engineering. And then mechanical engineering, of course, a lot of mechanical systems in lifts, right? The hoist, the shift, the brake, buffers, and a lot. So I will introduce most of the mechanical equipment in the lift system today. And then or next week, okay, because this one as you can tell from PowerPoint, there are quite a number of slides. So I may not have enough time to finish all today, right? Structural engineering. Lift is like trains, okay, railway trains. So, but trains run on horizontal tracks. You all know about that. And lifts run on vertical tracks. So they are similar. Okay. A train is being confined to run on the track horizontally, and then a lift is confined to or restricted to run along tracks vertically. So that involves structural engineering. Civil engineering. Why civil engineering? It's traffic. When you design a lift system, you need to study the traffic of the passengers and also the traffic of the lift tank. So this kind of traffic study is originated from civil engineering. But for civil engineering, we are talking about horizontal movement. But in lifts, it's like vertical transportation, vertical movement. You can treat a high-rise building as a city, as a small city, right? But if you let's say if you have a 100-story tall building, then it's a big city, not a very small city. Then in the city, and you need to convey peoples around the cities, like you need to convey passengers around the building. That is traffic. So it's a topic in civil engineering. And then of course artificial intelligence. Lift systems used it or employed artificial intelligence some how many years? Maybe 30 years, at least 30 years ago. Okay, in AI. Although we may not spend so much time on AI application, but I can tell you about when we go to traffic and control. Then I can tell you a little bit about AI application in lift system. Okay. Now, I think you are aware that in this coming semester, there are two modes of uh, classes. One is 3 hours per lecture, and then 10 lectures in total. Another mode is 2.5 hours per lecture and 12 lectures in total. In previous years, when I conducted this module or this course, I adopted the 2.5 hour model, right? Why? Because I need to finish all the lectures within 10 lectures. And then the final 2 lectures will be reserved for group presentation, all right? Now, group presentation is not just a piece of assessment tool. It's also an opportunity for you to learn from your fellow classmates, right? Because if you just listen to me, then you only get information or get the knowledge from one source, and then your classmates work on projects and then submit the reports, and they will do presentations. So in this case, you should change ideas, you should learn from one another, right? So that's why I will still adopt the 12 lecture mode, right? So altogether 30 hours, the same as before. Okay. So that's why from today onward, our lecture will be from 7 o'clock in the evening until 9:30, right? Because I'm not in Hong Kong at this moment, so that's why the first class has to be conducted by Zoom, right? But from the second class onward, I will meet you face to face. I will deliver the lectures face to face in Hong Kong in the Centennial Building. I think the second floor of CBS of the building. So you know about that. Okay, where is right now? This is the timetable. So today is a little bit special because before the Chinese New Year, I cannot come back to Hong Kong. I need to stay with my family. But right after Chinese New Year, I'll be back. So from the second week onward, and after today, we have a 2 week break. Okay, no classes for 2 weeks, and then the next one will be on February 11, right? So it's at a CPD 2.58 the classroom, and you can see as I told you before, lift systems so broad, we cannot for everything within just 10 lectures, right? So I'll pick those important topics like lift systems and safety devices. Safety is most important, right? Because it's a kind of a transportation tool. Right? When you are talking about transportation, safety is top priority. Safety, and safety. Okay, like you are riding a car or taking a train, taking a ferry or flying. Okay, in the sky. Then we'll talk about roofs. Roofs are so important in nowadays because the most lifts are still using roofs. Okay, maybe after 20 years from now, there will be less and less roof-based lift. And I'll talk about a little bit about the advanced lift when we talk about motor drive. Okay, some motor drive they don't involve roofs, no roofs at all. Now and then energy, because Hong Kong has the building energy code, and then lift systems, lift and escalator system is one of the four central building services systems in the building energy code. So I will spend some time on energy, and I have done quite substantial research in this area of lift systems, and then for the rest of the six classes. I will spend time on traffic analysis and then motor drive. Okay, motor drive is different types of motors. As I told you before, lift systems use the most advanced motor drives. Okay, in buildings. Okay. Okay. So and then on the April 15 and April 22nd, you will be doing presentations. All right, you need to submit a coursework. It's a group coursework, not individual coursework, but group coursework. So you have a group presentation, and then after a presentation, different groups will ask questions. Okay, so that you can have a chance to exchange ideas. And of course, Mr. Liu and I will also ask questions. So this is these two lectures is a good opportunity for you to exchange your research results and then learn more. Okay, not just from one source, but from different sources. Now, for the examinations, it will be a 2-hour examination from 6:30 to 8:30, but the date has not been confirmed. So I'll inform you once I get the information. Right? Okay, these are the references. Some are free, like the Guide D. Okay, in a library, I think you can download Guide D. CIBSE Guide D is a very comprehensive handbook on lift systems and escalator systems. EN81, I think, is also free from the library. Not free, but you can download from the library. Code EMSD code. The BC, this is the energy code. Energy code is free. You can download from EMSD's site. EMSD stands for Electrical and Mechanical Services Department. Right. This is a government, Hong Kong government department, responsible for ensuring lift and escalator safety in Hong Kong. And from time to time, I will talk about EMSD. Okay, this term. So remember, this is a government department. So you can go to the official website of EMSD and you can get more information about lift and escalators. Okay, they have a special division overseeing the safety of lift and escalator systems and also the energy performance of lift and escalator system. Core practice on the design and construction of lifts, I think that's not free. You need to buy, but no need to buy. If you can download EN 8120 and EN 8150 from this is the European standard. EN means European, right? And 95% of the design code in Hong Kong follow the European code. And then for my two books, you can borrow from library, but I don't think they have any electronic digital version. These two from the magazine. Elevator World is the world's largest magazine in lift systems. I think you cannot freely download. You have to buy, but no need to buy. Right, no need to buy. But if you want to dive into the more about lift and escalator engineering, then why not? Okay, that's not very expensive, right? But not compulsory. Okay, you don't need to buy. If you just download my PowerPoint and then listen to my lectures, then that will be enough. Okay, but of course, if you want to buy, it's okay. Okay, you go to the website of Elevator World. It's American elevator magazine, but it's international. Okay, so first of all, talk about the coursework requirement. Okay, what you need to do It's because it's it is 50% of the final score of your final score. So half of your final score is from coursework, another half, of course, from the written examination, right? Um, so that's why it's so important. Now, so first of all, form a group. Okay, not more than 6 students and not less than 4 students per group. Okay, and then send Mr. Lu your group details before the end of March, right? Before the end of March, um, and then put down your name, the name and student ID of each group member. Right? And then Mr. Lu will assign a group number for you. The group number is used for the sequential presentation. Okay, because Mr. Lu will organize which group will present first and which group later, and then which group will ask questions. And then now, there's no particular topic on the coursework. You just attempt any problem, okay, related to any topic, whether I have covered or not. Okay, even though it's beyond what I shall deliver, it's okay, no problem. Okay, practical or theoretical, up to you. Related to lift and escalator engineering, just spend your time and study a problem or do some design or whatever, right? But if you want to fail to play safe, then you can send your abstract. Send abstract to Mr. Lu. Copy me an abstract so that we'll tell you whether your what you want to do is acceptable or not. But first of all, form groups. Okay, as soon as possible, form groups. And if you have difficulty in forming groups, then you can ask for help from Mr. Lu. He will help you find your classmates and then form the groups. All right, not less than 4 and not more than 6. Now, if your study is on a real building in Hong Kong or elsewhere in the world, then you'll get credits, okay, additional credits. Um, uh, but the use of a local building is preferable. Why? Because you can do site visits. You can to visit the building and then get more information about the building, right? Or you don't want to work on the building, you don't want to work on design or solve a problem in the building, you can do something in general, theoretical. It's okay, but then you may need more mathematics and computer simulation and whatever. Okay. Now, if you work on the building, a local building, then you should do site visit and then get information like the building layout plan, the passenger circulation modes, statistics, lift and escalator arrangement, and all that. Okay, then that will form group part of your report because your report has two parts: the group part and the individual part. And I will talk about a little bit more about these two parts. Now, since it's an engineering course, you are doing an MSc in building service engineering. So derivation, calculation, simulation is preferable. Okay, don't just do descriptive or qualitative alone. But how much to you? Okay, you do design. How much you design? But at least in your report, I hope that to see some elements in mathematics, calculations or simulation or whatever. Right. That's why I make it red. So it's important. Now, the final report consists of the group part and the individual part. The final report is limited to 18 to 22 pages, right? Depending on the number of group members. Okay, why? Then you'll see when I talk about the structure of the report. Now, submit the final report in digital form to Mr. Lu on or before 5 p.m. on the first day of presentation, April 15, the first day of presentation. Remember, you need to send Mr. Lu your group details, the details of your group, by the end of March. Okay, and then on April 15, we have the first day of group presentation. So before 5 o'clock, send your report in digital form to Mr. Lu. Okay? All groups must send the report. Okay? Now, the group part is worth 50%, 15% out of 50, 15% out of 50%. 50% is the 50% of your final score, right? So so all group members share the same marks, okay, of the group part. And then the individual part. For the individual part, every group member prepares an individual part, but you bind every part together in one group report, right? So it's worth 20%, okay, individual score, so member by member. And then you need to do a group presentation of 15 minutes long and answer questions. That's worth 10%. And any member of the group can do oral presentation. So you can have more than one or just one member represents the whole group to do the presentation. No problem. Say mark, okay? Say mark for all group members. And then right before your presentation, oral presentation, submit 2 hard copies to me and Mr. Lu. Okay, Mr. Lu and me will be there to give marks. So submit 2 hard copies of the final report. Don't use color printing. Okay, it's expensive. So red and white will be good enough. Of course, your PowerPoint will be color, right? And then every group needs to ask another 2 groups questions, and that's worth 2.5% per question, right? This was invented by me in order to make sure that you fellow classmates can exchange ideas, okay? Can exchange ideas, and then and also other groups will not fall asleep when one group is doing presentation, okay? I don't want just me and Mr. Lu listening to the presentation, so everybody will listen to the presentation because you need to ask questions afterwards. So you can see all add together will be 50%, okay? And then out of this 50%, only 20% is individual. The remaining 30% are group, okay? Same marks for the whole group. Now, this is format of the final report, limited to 18 to 22 pages. Why 18 to 22 pages? Because you have 2 pages for each individual part. So if you have 6 members, that means 12 pages. If you have 4 members, 8 pages. That means 10 A4 pages for the group part, okay? Group part. So these 10 A4 pages will be consisting of title page with the name of each group member and ID numbers and group numbers as well. And 1-page summary, including the study of each member as well as a summary only. And then a description of the building or the problem, detailed study by each group member. So 2 pages for each group member. Conclusion and further works, right? Reference and appendixes. References and appendices are not included in the 18 to 24 pages limit. Okay, so you can have more. Okay, so suppose you have some appendices with photos, references, and all that, then you can go beyond the 22-page limit. But besides the references and appendices, you are limited to 22 pages for a 6-member group. Remember to indicate the author of each individual part within the report, because each individual part is worth 20%, right? So that's why you need to write down the name of the author of each individual part, okay? And so that I can give marks. Mr. Liu and I can give marks on each individual part as well. Send the soft copy to Mr. Liu. Mr. Liu, using this format, okay? Use this format, MEBS 7010-Vertical, and then the last name, okay, or the surname of each group member, right? And then .pdf. And then right before your presentations, submit 2 hard copies, right? Okay, some hint on the oral presentation. The whole group gets 15 minutes, okay, to do presentation, so not longer, just 15 minutes, right? And then remember to hand in 2 red and white hard copies right before your presentation, and then limit your slides to not more than 20. That of course, if you want more, it's okay, but 15 minutes, if you go beyond 20 slides, based on my experiences, it's not easy for you to finish more than 20 slides within 15 minutes, right? So including at most 2 slides for each individual part, and the remaining will be, of course, group part, okay? Maybe 10 slides on the group part as well. And then, so the suggestion, 1 slide on the project title and name of members, 1 slide on background, 5 to 6 slides on the building or the problem, and then 2 slides per individual part, right? And then 1 slide on conclusion. So 15 minutes. And then 2 other groups will ask your group a question, right? In 5 minutes. So altogether, you have about 25 minutes, okay? And then including some preparation, because you need to upload your PowerPoint onto the computer right before your presentation. Okay, so these are all for the oral presentation. Do you have any question at this moment? You can type and then I can answer. But if there's no question, no problem. Okay. In every lecture, I can answer your questions regarding the coursework, right? So no need to worry about that. Just digest what I just told you, right? And then what is important is try to form groups as soon as possible. Okay, as soon as possible. Okay. So um, so if there's no question, then let me start my lecture today. Get the laser pointer first. Okay. Oh, I received a question about the hard copy submission. You just bring the hard copy to the classroom, and then right before your presentation, then you hand the 2 copies to me and Mr. Lu. All right. So just 1 minute, 1 minute before your presentation, then just give us the hard copy. Right. Because the why we need a hard copy, because we'll immediately write comments on your hard copy, and then maybe we'll give some marks on your presentation. Otherwise, we'll forget, right? So that's why this is the reason why we need 2 copies from you. So you may print it both sides, and then try to save paper, right? Black and white, or draft mode. So no need to make it very dark. Draft mode, uh, up to you. Okay. So maybe on save paper, print it on both sides. Okay. Okay. Now let's start. Um, so again, I just mentioned that in Hong Kong, we usually use the term lift and escalator. Okay, not elevator. But in North America, we use elevator. Same. Okay. So there are different types of lifts. We have a passenger lift. So what you normally ride in is the passenger lift. Okay. Um, Passenger lift usually serve the passengers going around the building, and then you have the service lift. Now you can see here this service lift, and maybe you have some may be familiar with the service lift. A service lift is also called a dumb waiter. Dumb waiter. Okay, it's mainly used in the restaurants. In the restaurants, when suppose the kitchen is on the 4th floor, where the restaurants are on the 2nd and 3rd floor. Then in this case, a first, second, and third. Then after the serve prepare a dish, then he'll put it in the dumb waiter, and then send it to the 2nd floor or 3rd floor or 1st floor. And the waiter waitress will pick the dish and then serve you. Okay, so this is the service lift. Very often in buildings, the management, uh, 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 how to say, the management people will ask those who deliver goods to use a service lift in the back of the building or whatever. You can say that is a service lift because it's mainly used to transport goods. Okay, but from EMSD point of view, from the government point of view, is also passenger lift. Okay, whenever a lift can accommodate passengers, human beings, is called passenger lift. Okay, because it is something to do with the regulations by the law. Okay, so and any lift that carry passenger means passenger lift. Okay. Service lift, small, very small. No passenger can be conveyed by a service lift. And then goods lift. This is kind of goods lift is used in the factory. It is not governed by EMSD. It's governed by another organization in Hong Kong. It's a labor department, right? And lifting platform. This is a special lift used on the stage or the factory and or whatever. And then stair lift. I think you have seen stair lift very often at the MTR stations, right? And then vehicle parking system. Okay, vehicle parking list is mainly for cars, okay, not for passengers. So these are the common type of lift you can see. Now, this accidents were I was involved in investigating these accidents. Although many years ago, that just told you that operation of lifts and can sometimes be dangerous if they are not well maintained. Okay, So I see a typo. All the hoist ropes, all the ropes were broken. Okay, and fortunately, the lift was stopped by a device called safety gears, and I'll talk about safety gears later. Okay. So then no, the car will not fall down. Otherwise, there's a free falling of the lift. It will be very dangerous. Passengers inside will get seriously injured or get killed. Okay. It happened in 2008. And then another serious accident in 2010. The counterweight was detached. Okay, detached, and the counterweight actually hit the car. And I'll show you the structure of the lift system. Then you know where's the counterweight and where's the car afterward, right? And then this is the frame of the counterweight, right? And this is the car. And remember, the car is the cage that houses the passengers, right? And then in 2013, another serious accidents, and maybe if you pay attention to the news, then you may remember this accident in North Point in the restaurant. In the restaurant, I think 12 passengers. They are all aged passengers, and they want to go to a restaurant upstairs. Then they ride the escalator, the lift, and then suddenly there was an accident, and the lift was just fell a little bit, not free falling, but fell a little bit. And then the passengers were injured, and they were all sent to Queen Mary Hospital. Right, it was 2013, more than 10 years ago. Right? Now, why should we concern lift and escalator safety? Why? Because a normal citizen in Hong Kong lives at least 4 times, okay, on a weekday. Why? Because you leave your home and then you go back to your office or the school, university, and then you take a lift in the campus, and then when you leave the campus, you take a lift and then go back home. You take a lift again. So at least 4 times, at least, and then 4 escalators 4 times because you use MTR, right? When you are using MTR, then you always need to use escalators. That's why and lift and escalators in Hong Kong are used very frequently. Okay, you know, for a lift in Hong Kong, we're talking about 40, at least 40 during the peak hours, at least 40 trips or 40 on-off trips per hour. In Europe, they're talking about uh, 1 to 2 or 3 trips per hour, okay, or journeys per hour. But in Hong Kong, we're talking about at least 40. So that's why I mean very busy buildings. So that's why citizens concerned with the occurrence of accidents because we use lift and escalators many times a day, and the government concerned because government has a special division, the lift and escalator safety division of the EMSD, Electrical Mechanical Service Department. So go to EMSD website, and then you can learn more about lift and escalator systems from the website. So when you are working on your coursework, so you need to assess the official website of EMSD. I think it's emsd.gov.hk, something like that, and then go into the lift and escalator part. There you can have many documents, okay, related to lift and escalator safety, and then the whole industry concerns. Now, legislation. We have a very strong, okay, law, okay, on governing the safety of lift and escalators. And then in the past, from 1960 onward, the name of the law was called Lift and Escalator Safety Ordinance, Chapter 327. Okay, but from 2012 onwards, we EMSD changed the law, and then now it's 618. I think you can download Chapter 618 from the website, okay, of EMSD, or from I think there's a website on all the laws in Hong Kong, enacted on April 18, 2012. But again, no need, because this is a technical course. Okay, you are not studying law, so unless in your coursework you need to refer to some laws. Otherwise, there's no need to download. Okay, download the law. Okay. You just know that we have a Chapter 618 now being active. And then in Chapter 618, associated with two regulations, lift and escalators general regulation, that is to do with responsibilities of the responsible persons, the engineers, the workers, and responsible persons means the owner, the management guys, and whatever. All right. So, and then we have a fee regulations. So you need to pay. Okay, you want to run the lift, you want to operate a lift, then you need to pay. Okay. And then control a lot of control measures, and then governs all lift and escalators in public and private sectors. In the 3 to 7 days, half a century ago, 3 to 7 did not govern lift and escalators in government buildings. But now, 618 governs all, okay, all lift and escalators in Hong Kong. Okay, and then in 618 with the term responsible persons. Okay? Responsible persons means owners, managers, and controllers of lift and escalators. In the past, only the owners were responsible for lift accidents, but now, according to 618, managers and property management companies and controllers of lifts also responsible, okay, for lift safety. Okay, so you can see here, LP, owner, and or any person who has the management or control of the lift, right? So in the past, as I told you, in the past, only the owner of the lift were responsible. And if there's any accident, the owner just needs to pay the penalty. Okay, that's all. But nowadays, if the owner is not has not done the job, then he may be penalized to imprisonment. Okay, need to be imprisoned. So that's why nowadays the lift safety is much higher than past. And the owner of the lift may appoint a responsible person, that's the property management company, okay, to control, govern, and sorry, not to control and operate and maintain the lift. Okay, so usually it's simple. The owner is a responsible person. The owner will hire a property management guy or himself, whatever. Okay, a property management guy to maintain or operate the lift, and then this property management guy will hire a registered lift contractor to maintain the lift, right? And then the registered contractor will hire engineers and workers to actually carry out the work. So these are the steps, okay? These are the steps. And then 618 also stipulates the requirements of the equipment, okay, safety type tests. So some devices needs to be type test. Type test means they need to test the design of it in the laboratory, okay, in the international laboratory. So not the whole lift system needs to be type test, but some important like the safety gears. And I will talk about all these important devices later. Okay, type test, and then type test means you just test the design. You don't need to test every component, every I mean every installation. No need, but the design. Okay, and then quality control. You need to use registered lift and escalator contractors to install, maintain, repair, or do alteration, demolition of lift and escalators. Okay, these are all stipulated in the 618. And then safety examination. Now, safety examination is important. For lift, every lift needs to have a very, very comprehensive examination every year. Okay, every year for lift. For escalators, because escalators are for public, okay, more frequently used by the public. So that's why 6 months. Every 6 months, you need a very detailed, thorough examination. Okay, and then for the rest of the time, you just need to carry out maintenance. So maintenance is monthly basis. But safety examination yearly for lift and half yearly for escalators. And then 618 also set the standards of maintaining the lift, and you can see there's a code of practice for lift works and escalator works. You can download it. Okay, you can download it from the EMST website. Okay, this is free. It's free. But this one is only it's mainly controlling what works have to be done during maintenance and during yearly maintenance, right? So maybe when you are doing your coursework, this document is helpful. Okay, you need what have to be done on a yearly basis or a monthly basis, right? And registered contractor needs to attend failure of emergency design devices of lift and escalators within 4 hours. All right. So these emergency devices include alarm, emergency lighting, intercommunication. Intercommunication means the communication between the lift car and machine room, okay, or the management office, okay? Ventilation fan, or that. Okay, we don't want to go into the details because these are the legal requirements, not technical. So I just brief you what 618 is. And then prosecution. If the responsible person is not responsible for the lift, then EMSD can prohibit the use of the lift and then even sue the responsible person, the owner, the property management guy, um, and then the maximum fine is 200,000 Hong Kong dollars, and the maximum imprisonment is 12 months. So, people are not afraid of paying the fine, but people are afraid of being imprisoned, even a week. Okay, so imprisonment is more useful in making sure that the responsible person pay attention to the safety of the installation. And then registration, register contractor and register engineers, okay, and then register workers. So these are three types of we call these guys of qualified persons, and they are registered contractor. Registered contractor is the guy who is controlling the business, okay, the company of to do maintenance. I think in Hong Kong now we have about 40 plus registered contractors in Hong Kong, and then we have a few hundred registered engineers. We have registered lift engineers and registered escalator engineers, and then we have thousands of registered workers. Okay, now engineers and workers have different responsibility. Registered engineers are mainly responsible for testing the lift and escalators, testing, and then registered workers are responsible for installing, maintaining the lift and escalators. Okay, but usually in Hong Kong, the registered engineers are the boss of the registered workers, usually. Okay, but not necessary, but usually. Okay. And then public monitoring. Okay, the public will also monitor the safe operation of lift and escalators and report to EMSD when something wrong. Now, there's a logbook. Okay, in the past, a logbook was kept inside the machine room. Okay, inside the machine room of the lift or escalator. And then every time when registered worker or registered engineers attend to site and then carry out maintenance or examination or testing or whatever, they need to fill in the logbook. Okay, so it's a hard copy in the past, a hard copy. And then now EMSC is adopting the use of electronic, okay, digital logbook, e-logbook. Okay, so maybe in your coursework you can study whether the e-logbook is effective or not, whether it's easy to analyze the data or not. So maybe you can analyze how to analyze the different category of problems, okay, through the e-logbook. So this is also one way of. As I told you, it's free to whatever topic you want to do in your group project. Okay, it's very free. So you can even do something beyond what I shall be deliver, okay, within in the coming weeks. Okay. So register contractors, register engineers. I think I should need register workers as well. So all three guys, all three type of people will fill in information in the logbook. Okay, either paper or digital. All right. Now these are the this one is called the design code for practice on design and construction of lift and escalators. So I think you cannot download it freely. I do not know whether you can download it from library, but I don't think so. Because you can go to check whether you can download it. This is useful. Okay? This is design code. A lot of technical information inside. Why you need to buy it instead of download it from the EMSD website, because they copy a lot from the EN standard. Okay, for EN standard you need to pay you need to buy. That's why from the design code, you also need to pay and buy, right? So if you can download it from the library, it will be good. But otherwise, no need to buy. No need to buy. Okay, there's no need because you are not you are not working in the lift and escalator industry. No need to buy this design code. Okay, and then but this one is free. You can download it from EMSD website. The core practice for lift works and escalator work. This um this book will advise you what maintenance work needs to be done, what testing, examination works needs to be done. Okay, so this is more on procedures. This one is was written by EMSD on procedures. And this one also written by EMSD, but they copy 95% from the European standards. Okay, so this one is not free, and this one is free. Now, this one is from the Labor Department. I think it's free. You can download it from the Labor Department website. It's free. It's called the core practice for safety at work. All right. So this one is mainly addressing the safety of the maintenance people. Okay. So for example, they will tell you about the management system, facility safety, safety practices, and whatever. Okay. And also the safety officer, the role of the safety officer as well. This one quite old, but still they're still using 1997 edition, right? They're still using this this book, right? So it's free. Since it's free, you can download a copy. Then you know what safety precautions need to be done. Okay, but it's not technical. It's not technical. Okay, now maintenance. As I told you before, we have different types of lift works and escalator works. Now, for example, installation, new installation. When you install a new lift or new escalator, it's called installation. Commissioning. Right after installation, you need to test whether the installation is normal, okay, is up to standard or not. This is called commissioning. Commissioning is the testing procedure or adjustment procedure right after installation. Okay. Then after that, then the registered contractor will inform EMSD. Then the EMSD will send inspectors to check the installation. If they are satisfied with the installation, then a permit will be provided. Then this lift or escalator can be open to the public. Okay. Now, and then every year you have examination. Every year examination, and every 5 years the examination will be more how to say more detailed. Okay, because yearly maintenance you don't need to involve real load, actual load. But for 5-year examination, you need to have involved actual load. Okay, for lift. Okay, for not for escalator. For escalator, you never use real load. Okay. But for lift, you used to wait, okay, to imitate the passengers, and then maintenance. Okay, maintenance is on a monthly basis. Also, the law requires that every lift or every escalator be maintained not with a period not longer than 30 days. 30 days. Then, in order to comply with this law, so usually this in the practice, usually in the industry, the registered contractor will maintain the lift or escalator every 2 weeks. Every 2 weeks. That's the industry standard, not the law. The law asks for 30 days, not more than 30, not a month, but 30 days. That means when you finish maintenance, and then not longer than 30 days afterwards, then you need to do maintenance again. And that's why, in order to be safe, so you do it every 2 weeks, once every 2 weeks. Then make sure that you will not breach the law. And then repair means there's some fault, then you need to carry a repair, some fault. Alteration. So for example, when the lift is old, becomes old, escalator becomes old, you want to change. For example, people like to make it look good, so they like to change the doors, they like to change the wall of the car, inside the car, because passengers will walk inside the car. But for safety purpose, sometimes they want to upgrade the motor drive and all that. Okay, safety devices, there's alteration. Demolition. If you want to take away the lift and then build a new one, then it's called demolition. All right. So all these are considered lift works or escalator works. So whenever you have a lift or escalator works, you need to use a higher registered contractor. Okay, and the registered contractor will have qualified persons to do it. Okay, qualified persons means registered contractors, registered engineers, registered workers, right? Okay, and then so this you can see qualified persons means registered contractors, registered engineers, or registered workers. Okay, now remember we have a registered lift contractor, registered escalator contractor, like registered lift engineer, registered escalator engineer, right? All that. And then and also for service lift, goods lift, and vehicle parking system, we also need to hire registered contractor, okay, to do it. Okay. So so the registered contractor must ensure their lift maintenance works. Now maintenance every 2 weeks, right? Every 2 weeks. It's usually in the trade we call it oiling, oiling. But it's more than oiling. What's meant by oiling? Oiling means provide some lubrication. You know the mechanical devices. The mechanical devices have a wear and tear. Okay, so you need to lubricate them, the part. Whenever two pieces of metal are in contact with each other and they are moving, okay, sliding from each other, then you need to provide lubrication. Then this is called oiling in the trade. And you need to do adjustments, cleaning, inspection, and all that, right? So all these are done by the registered workers and then tested or examined by the registered engineers. Um, so these are the responsibilities of the registered person, okay, or the qualified person, okay. I don't want to go into details for this. Okay, now before the break, let me give you the structure of overall structure of a lift. Okay, as I told you before, this course is although as elevators include as lifts and escalators, but escalators are more lower priority. I don't mean they are not. The safety is not important. Safety is very important for escalators because escalators, more passengers are using escalators than lifts. But technical speaking, a lift is more advanced, more sophisticated than escalator. So that's why in this course we will focus on lift. Right now, there are two types. There are two types of lift. The first type called traction lift. Traction lift means we use ropes. We use hoist ropes. Right now, there are two types in general. Now, this one is with machine room, and this type without machine room. So this is called machine roomless. Machine roomless, or in short, MRL, machine roomless. Okay, let's talk about the more conventional lift. It's the traction lift with machine room. Now, with machine room means you have a room, machine room, usually above the top of the hoistway. This is called a hoistway. Hoistway is a tunnel, the tunnel where the lift car is moving along. Okay, you can call it a hoistway or you can call it a lift shaft, okay, or hoistway. Now, and then first of all, you look at the car. This is the car, as I told you. The car is the cage, okay, the cage where the passengers go in. Okay, now then you can see in the car there are doors, and these doors are called the car doors. Now you have two types of doors: landing doors and car doors. But maybe you are not aware of that. Okay, because when you go inside a lift car, you just see a pair of doors. Okay, but actually there are two doors: the car doors and the landing doors. Landing doors means the doors attached to a landing. Okay, the doors cannot move. I mean, they can move, but cannot go beyond floors, between floors. The car doors are with the lift, okay, with the lift car. So that's why car doors will move vertically, okay, with the lift car. But there's no mechanical power. There's no power for the landing doors. Okay? The landing doors are passive, but the car doors is not passive. Above the car doors, you have a motor called door operator. This motor is responsible for opening the car doors and closing the car doors. So, but of course, you need power. Okay, you need power. Now, how can you get power in the lift car? You see, traveling cable. So there's a traveling cable. This is a soft cable. Okay, traveling cables, soft cables, and then these soft cables are responsible for doing two things. First one, it deliver or convey electric power to the lift car, because inside lift car you have a lot of power consuming devices like the ventilation fan, air conditioner, the signals, and all that. Okay, so you need power, lighting. Okay, lighting inside lift car. That's why you need power from the traveling cables, and then signals. Okay, signals from traveling cables. Okay, the communication between the lift car and the machine room. Okay, and also intercommunication. So if somebody is being trapped in the car, he or she wants to talk to somebody in the machine room through this traveling cable. Right? This trunk cable are soft, no force, no tension. Okay. Now, and then, so the operator is a motor, takes power from the traveling cables, and it opens where the car is at the landing. Now, if the car is not at the landing, the top operator cannot open the car doors. Okay, only when the car is at the landing, then the operator can open and close the car doors. Now, there's a mechanical linkage between the car doors and the landing doors, the landing, right? So when the operator opens the car doors, the landing doors are also open at the same time. Okay, and if the car wants to leave that landing, then the operator will close the car doors and automatically close the landing doors. Right now, then you can see the hoist ropes, and it's also called suspension ropes. The suspension ropes are not suspending the car directly. You can see here, you have the frame. This is called the car frame. Car frame. The suspension ropes are suspending the car frame. Okay, a car is actually floating inside the car frame. Okay, inside the car frame. Okay, so when the car frame moves, the car moves as well. These ropes will go up to the machine room and then go around the drive shift, and then to a diverter pulley. This is called the diverter pulley. The diverter pulley's responsibility or role is to make sure that the car is away from the counterweight. It's the counterweight. Okay, I think you know you can guess the job of the counterweight here, right? When the car is half loaded, and the brake is released, if since the counterweight is a weight equal to the empty car plus half of the full load passengers. So if you release the brake, the car will not move. But if there's nobody inside the car, then the counterweight is heavier, and you release the brake, the counterweight will go down, then the car will go up. Or if the car is full loaded, then the car size is heavier, and you release the brake, then the car will go down and the counterweight will go up. So the counterweight's job is to balance of the load of the car. Then the motor and the motor torque can be reduced a little bit. Okay, you don't need to drive and so hard. The motor drives so hard. And you can see here, the ropes, the hoist ropes are not how to say tightly terminated on the shift. It's just laid on the shift and then go to the diverter pulley and then go down to the counterweight. So how you move the car is by friction. So that's why we call it traction. Okay, by friction. When the motor rotates the shift will impose a force on the ropes by friction. Then the car will go up and down. Okay, of course the motor can rotate in both directions. Okay, and the drive can rotate in both directions as well. Right now, and then this one is called the overspeed toughener. The overspeed toughener is used to detect the speed of the lift when the lift is going downward. Okay, if the lift is going downward under very high speed, over the rated speed, then the overspeed toughener will do something and then trigger the counterweight. And then trigger the safety gears. The safety gears is the last safety gear. Okay, is the last means of safety protection of a car. Okay, even though all the ropes are broken, then the overspeed toughener can detect a free falling of the car, and then, or even not free falling, but when the car is overspeeding, then the safety gear will be operating and the car will be stopped. Okay, and I will talk about safety gears more later. Okay, and then apron. The apron, what's the job of the apron? When the car is slightly above the landing, and if the landing doors are open, you have a hole underneath the car, and if you stand there, it's very dangerous. You can slip through the hole and then fall down. Then you get killed because they are under the at the bottom of the hoistway. It's called the pit, lift pit. Okay, underneath the at the hoistway, at the bottom of the hoistway, there are a lot of equipment there. So if you fall down, let's say from 5 floors, okay, down to the pit, then even though you are not get killed, you do not get killed, you're seriously injured, right? So this apron is to fill up the gap hole. Of course, if the car is far away from the landing and if the landing doors are still open, then it will be hole there. It's very dangerous. Okay, but the landing doors, although the landing doors cannot, there's no power, but it can be closed themselves. Okay, the landing doors can be closed themselves. Okay, it's a mechanical. It's easy, passive. Okay. And here you can see it's called lift well. That another term, hoistway, lift shaft, lift well. Okay, and there is at the bottom is called the lift pit. Now and then you have buffers. Buffers is to stop. So if the car goes down after it passes the lowest floor and then it continues to go down, then the car buffer will stop it. Or the counterweight goes down, that means the car will continues to go up. Then the counterweight will hit the buffer, it will stop it. Okay, so it's a stopping safety devices. Guide rails, you can see the guide rail here. Guide rail are just guide rails of lift car is the same as the guide rails of trains. Okay, the lift car move along the guide rails. Right? And then you have the motor, you have the controller, and you have the brake. Between the motor and the shift, you have the brake. Okay, the brake is used to brake the shift. So actually, the brake is not braking the ropes directly. The brake is braking the shift, and then the shift by friction, by traction, will brake the ropes. Right. So if you have oil on the ropes, okay, no friction, no traction, and even though you brake the lift, it's no use. Even though the brake is functional, it's no use, right? Okay, so these are the main function of the counterweight. Oh, okay. Somebody wants to know. I repeat counterweight. Now, as I mentioned before, the weight of the counterweight is equal to the weight of the empty car plus half, usually half the passenger. Okay, suppose the car can accommodate 1,000 kilograms. Suppose that the car itself is a weight of 2,000 kilograms, and then it can accommodate at most 1,000 kilograms. 1,000 kilograms passengers about 13 passengers. Usually, the standard is 75 kilogram per passengers. Okay. Of course, for ladies, they will be lighter. For men, it will be heavier, right? But on average, 75 kilogram per passenger. That is the allowance. So 1,000 kilogram passengers and 2,000 kilograms of the lift car, empty lift car, because the lift car is very heavy. Sometimes you have air conditioner above, right? Now, then the weight of the counterweight will be 2,000 plus 500. That means if the number of passengers inside weight 500 kilograms, so the total weight will be 2,000 plus 500, so 2,500. Then this counterweight is about 2,500. And if you release the brake, the system will not move because balance. But if the lift car is fully loaded, then the car will go down because heavier on the car side. Or if the car is lightly loaded, nobody inside the car, then the counterweight will be heavier. The counterweight will go down, right? So this is the function of the counterweight. Now, but the most important function is to reduce the torque exerted by the motor. If you don't have the counterweight, when the motor drives to when the motor tries to drive the lift car upward, the torque will be how much? Will be 3,000 full load, 2,000 kilogram plus 1,000 passenger, 1,000 kilogram passenger, and then 3,000 kilogram, and then times 10 will be 30,000 Newton, okay, of force. Then it will be the burden on the lift motor will be very much. However, if you have the counterweight, then you just need to the motor just needs to provide the unbalanced side. So suppose it's 400 kilogram passenger here. Okay, that means there's an unbalance of 100 kilogram only. 2,500 here, 2,400 here. So 1,000 kilogram, 100 kilogram unbalanced. Then the motor is just needs to lift the car up or down for 100 kilogram of force. 100 kilogram force. That is the function of the counterweight, right? All traction systems have counterweight. The tram. Perhaps all of you have already been using the tram, right, to go up to the Victoria Peak. The tram is a lift. The tram is not vertical. The tram is slanting. Actually, there's a slanting lift. At Sati is a Beaufort-San. I don't know the English name of the site. It's called Beaufort-San. They have a slanting lift. Okay, so lift may not be vertical. Yeah, but usually it's vertical. Okay, well, usually vertical because the 618 define lift as vertical movement. So if you have a slanting lift, it's not governed by 618, chapter 618. Okay, another ordinance, another law. Okay, now and nowadays in modern times, we have another development called machine roomless. This is a machine room. Machine room has a disadvantage. You need a room above the roof of the hoistway or the lift shaft. So waste a lot of space. So that's why they say, oh, why not put the machine inside the hoistway? You can see you have the machine inside the hoistway, right? And you have the you also have the governor, you also have the guide rails, you also have the motor, the sheath, the brake as well. Okay, so you put the machine inside the hoistway, and then you don't need machine room. Okay, so all the safety devices same. We have buffers, you have guide rails, you have counterweight, we have all the safety equipments. Okay, um, uh, 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 safety equipment inside traction, a regular traction. Yeah, one of your classmates is very smart. Say more difficult to do maintenance. Correct. How to do maintenance? You go to the top floor and then you open the car doors and then you put a platform, movable platform. Okay, it's like a bridge. Okay, a bridge, a platform on the top floor, and then you walk on the platform, and then you can do maintenance on the machine and all that. So since there's nothing below the platform, so if there's something wrong with the platform, you fall down. So that's why it's not very safe. But if you work inside machine room, it's safe. It's a room, okay, safe. So correct. More difficult to repair the gear, but of course there are a lot of requirements on the platform, the maintenance platform for machine roomless. Okay, is more and more common nowadays, and the rated speed of machine roomless lift is also increasing. Okay, so a lot of lift serving bridges, okay, or skyovers and all that, they have a machine roomless, okay, lift. And why we have more and more machine roomless lift? Because of the popularity of a kind of motor called a permanent magnet motor. When we go to motor drive, then I will talk more on permanent magnets. And there are two types of motors: the axial field machine and the tangential field machine. This type of motor we call the tangential field machine. Okay, more conventional. But in machine roomless, we sometimes use the axial field machine. So there are different types of motors. Okay, we'll talk more about this when we come to the that part. Okay, so let's have a break of 10 minutes, and then we'll come back, and then I'll talk more about the safety devices. Right? If you have question, then okay, I can answer one question now before the break. Whether there is any requirement for the ventilation or windows required for MRL. Yeah, there are small windows, like the traditional machine room, not rest, machine room at lift. Okay, you have small holes on the floor. So when the lifts are moving, it's like a piston. Okay, you draw air into the lift shaft. So because the machine room is on the roof of the building, and then the machine room has windows, so fresh air will come into the machine room from outside. And then when the lift car is going downward, it will draw air through the small holes, and then the whole hoistway will be full of fresh air. Okay? Like machine roomers, same. Okay, same. You need to have holes at the top of the hoistway. Okay, therefore for ventilation purpose. But anyway, there are gaps. There are gaps between the doors, landing doors, and car doors. There are small gaps. So when the cars are moving, air from different floors can go into the hoistway through the gap of the landing doors, or coming out from the shaft as well. Okay, so don't worry about that. And then on the top of the lift car, you have a ventilating fan. So the fan will draw air into the lift car, right? So you won't get suffocated in the lift car. All right, so let's have a break. Now is 8:13. So come back by 8:23. Okay, 8:23. Uh, uh, from one of your classmates regarding the direction of rotation of the lift motor. Um, I think your classmate is correct. All lift and escalator motors must be able to rotate in two directions, right? And that is why I say lift motors or escalator motors are most advanced in buildings. Think about motors applications in buildings. Um, uh, uh, for example, pumps, compressors, fans, they are all rotating in one direction, right? I don't think you can see a fan rotating yeah, for some ceiling fans they can rotate in both directions, but usually the fans can need to rotate in one direction. And then for pumps, for compressors, of course, sorry, I need to close the door. So for pumps, for compressors, for fans in the air conditioning systems, they usually rotate in one direction. So the first one, it's unidirectional versus bidirectional. The second one, for pumps, fans, compressors, all these, what you're concerned are the steady state movement, right? Steady state rotation. So you don't care how the motor accelerates or decelerates, right? For fans, because for fan, you what you need from the fan is the delivery of air, okay, into your environment. So you don't care how long it accelerates. Of course, it cannot be too long, right? But how long it accelerates, how long it decelerates, you don't care, right? Pumps, provided that it can speed up from 0 to the required speed within seconds, then you are satisfied, right? But lift, the most difficult part of lift motor control is acceleration and deceleration, not rate of speed. Rate of speed is so easy. It's so easy. Acceleration, decelerations are difficult, and we'll talk about that in during the last three lectures of this course, right? Because you are talking about conveying passengers inside a lift car. So if your acceleration and deceleration control are not good, um, people will get sick. So that's why lift motors needs to be so advanced, right? Okay, now so just forget about this one. For the hoist ropes, I'll talk about hoist ropes next lecture. So in details, more details. So now we go back to the structure of a lift system. Now, the one that we talked about before the break is traction motor, and another type is called hydraulic lift. Hydraulic lift is less common, but we still have quite an amount in Hong Kong and elsewhere around the world. Now, for hydraulic lift, that means is there's no ropes, no rope. Of course, some hydraulic lifts have ropes, but not very common. Usually, common type of hydraulic lift in Hong Kong, they are all ropeless, right? So you see you have a piston. Sorry, you have a piston, and then down there you have a cylinder. You have a cylinder. It's a cylinder. The cylinder is you drill a deep hole into the ground, okay, And then, so usually the height of the, or we call the rise of the lift. The rise of the lift is the same length as the length of the cylinder, because the piston needs to go into the cylinder when the car is at the first floor. And then when you want to go up, and the oil will be pumped into the bottom of the cylinder, and then by hydraulic pressure, the piston will be lifted upward, and the car will go up. Right now, then you have a pump. So you don't need a machine room at the top of the hoistway. You just need a pump by the side of the usually the lift pit. By the side of the lift pit, you have a pump. You can see here. This is the tank, the oil tank with oil inside, and then you have the motor, pump, and a filter. Filter is used to filter the make sure the oil is clean, right? And the motor is immersed in the oil, because oil is insulator, so don't worry. Okay, there will not be any short circuit. It's an insulator. So the motor and pump are immersed in oil, and motor rotate. The pump will pump oil into the cylinder. So when the pump pump oil into the bottom of the cylinder, the piston will go up. And if you want to the car come down, then you release oil from the cylinder, then the car will come down. Okay, so of course you need control. You need control the acceleration, deceleration of that. Now, besides this drive, every safety device is the same. Okay, you have a buffers, you have safety gears, you have a landing doors, you have car doors, traveling cables, or guide rails, all the same. Okay, all the same. Now, and then rope configuration. So you can see here, this is just as how to say the block diagram of a lift. It's not real. Why? Because the traction shift is not that big. The drive shift is not that big. Usually it's about 600 mm to 800 mm. Okay, less than a meter. So if the distance between the ropes here and the ropes of the counterweight is just 1 meter, then when the counterweight is going downward, it will hit the car, right? Because the car is so big. Usually the car is big. That's why we need a diverter pulley. Okay, so you see here, we have a diverter pulley. So this one is the shift, and this one, sorry, this is at the bottom. No, so this is not a good example, but it's a diverter pulley by the side. So that the ropes coming out from the car will go around the shift, and then to a diverter pulley, and then down to the counterweight, right? So that to make sure that the distance between these two sets of ropes will be spacious enough, wide enough, right? Now, and then you have this type of drive at the pit at the bottom of the hoistway. It's not common, but we have this type of lift drive in Kowloon City. When we still got the Kai Tak Airport, the old airport. Because of the old airport, there's a height limitation of buildings in Kowloon City, because it's down below the path of the aircraft. So you try to limit the height of the building. So no machine room on top of the buildings. Then they have to build the traction shift and the motor. Okay, and the motor down below the lift pit. Right. Then you have a diverter pulley. It's also called, these two are also pulley. Okay, and this counterweight. And the ropes that needs to go down. So it's now don't feel that long ropes are good. Long ropes are not good. Okay, try to keep the optimal length of the ropes. Okay, if you have longer ropes, then you have more trouble. Okay, with maintenance. Like this one is good. You can see here, you have the shift here with friction, with traction, and then you have the this is diverter pulley. This is the traction. Okay, this one is the traction, the drive shift, and this is the diverter pulley, or called inflector pulley. Okay, now the difference between a shift and the pulley, the drive shift and the pulley, is that there's no friction on the pulley. So it's just used to space out. Okay, to space out the ropes. No friction. So there's friction on the traction shift, right? And then how can the ropes lay on the shift? You have grooves. You can see grooves here. So you have a cross-sectional wheel. This is a cross-sectional wheel of the shift. So you have grooves here. So there are usually three types of groove: V groove, U groove, and then U groove, V groove with undercut. Okay, undercut. So there are different types of grooves, and then there's for different speed, greater speed of the lift car. Okay, and when we talk about ropes next week, I mean 2 weeks after today, we'll spend more time on the different types of groups. Okay, what is the advantage of the V? What's the advantage of U and U with undercut and something like that, right? And this is called double wrap. Double wrap means this is a single wrap. Single wrap means the ropes from the car will go up and then around the drive sheath or traction sheath, and then go around the diverter pulley and then come down to the counterweight. Okay, this is single wrap. For double wrap, the ropes will go up from the car and then lay on the traction sheath and then go around the diverter pulley and then come back again to the traction sheath and come back to the diverter pulley again and then go down to the counterweight. It's called double wrap. Okay, so that's why you can see the ropes are actually in contact with the drive sheath and the diverter pulley 2 times. Okay, and what's the advantage? The advantage is increase the friction, the traction, increase the traction, so that the force on the ropes can be higher. Okay, the traction is high, the friction is better. Okay, and we'll talk about this when we talk about ropes next time. Okay, and these are the different types of configuration, and I think most common type are A and C. Okay, A and C. E is also common. This is double wrap. Okay, double wrap. But the A and C are more common. So A, remember you have the diverter pulley. Otherwise, this kind of way will hit the car, right? So you need the diverter pulley and no force, no traction, no friction on the diverter pulley, and then friction on the drive sheath. And this is called 2 to 1. 2 to 1. This is 1 to 1. 1 to 1 roping. 1 roping. And this is 2 to 1 roping. And I think you can guess the advantage, the merits of using 2 to 1 to increase the force, right? Because the tension of the ropes here is the same as the force on the car. The tension of the rope here is the same as the tension on the force on the counterweight. But this one, the force of the car is equal to 2 times the tension, because the tension along here is the same as tension along here. Why? Because this is also a diverter pulley. Diverter pulley has no friction, so it will not add force on the ropes. Since it does not add force on the ropes, the tension on this side of the ropes is the same as the tension on the other side of the rope. So same tension. So T here and T here. So the force on the car is equal to 2T. The force on the counterweight is also equal to 2 times the T. But the T here is not the same as the T here. So suppose you call it T1 here, it's to be T2 here. Why? Because you have friction here. The friction means the drive sheath will add force on the ropes. So the tension along this side is not the same as the tension along the other side. Okay. Oh, question here. Is there any kind of way for hydraulic lift? Yes. Okay. Sorry. If there's roped hydraulic lift, yes. If there's no rope, no kind of way. Okay. For with cylinder alone, no ropeless hydraulic lift, no kind of way. Okay. So A and C are most common type. Okay, most common type. Now you can see from photos here, as I told you before, the hoist ropes. The hoist ropes are not connected to the car directly. It's connected to the car frame. This is the car frame. Okay, and this is called the crosshead. Crosshead is of the car frame called the crosshead. So the ropes are attached to the attached to the car frame, and then the car is floating inside the car frame. Okay, so when the car frame is being pulled up and down, the car will move at the same time. Right, and then this is the car top. This is called the car top, so that the maintenance people can stand on the car top. And then you have the light, and there's the control button. Red button here is to emergency stop, so stop the car from movement. Remember, when somebody is standing on the car top, when you operate the lift, it can only move under very low speed. It's called the maintenance speed. Okay, maintenance speed. Maintenance speed is usually about 0.25 to 0.3 meter per second. Okay, very slow. It's very dangerous if you use rated speed when somebody is standing on the car top. Very dangerous. Don't think that you are playing in the Disneyland. Okay, not this is not this Disneyland. This is industrial safety, right? Then when somebody stand on the roof of the car, then you can do maintenance. Okay, you can check the doors, check the roofs, you can check the guide rollers. All that. Okay, the guide rollers are rollers like the wheels of the train. Okay, guide rollers because I told you before, you have guide rails on both sides of the lift, and then when the lift goes up and down, the guide rollers will be running on the rail, just like trains wheel on the train, right? And the operator, I talked about the operator before. The operator is a motor, okay? It's a motor, and it's responsible for opening and closing the car doors. Remember, car doors, not landing doors. There's no door operator for landing doors. Only door operator for the car door. But remember, when the car is at a particular landing, the car door, there's a mechanical linkage between the car door and the landing doors. So when you open the car door, the landing doors will also be opened automatically. When you close the car doors, the landing doors are also closed automatically. Okay. Now, but if the car is not at the landing, and if the landing doors are open, okay, then there's an automatic device that close the landing doors. Because I told you before, if the car is not at the landing and the landing doors are open, you have a big hole there. And if you are standing in front of a big hole, there's a high chance for you to drop into the hole. And then if you drop in the hole, then you'll get seriously injured, certainly, okay, or get killed. Okay. The mechanical system is simple. It's simple. There's a rope system with a small counterweight. So when the landing doors are open, the counterweight, the rope's arrangement will lift up the small counterweight, a small weight, not counterweight, a small weight. Okay, small weight. So if the car is not at the landing, then that weight will try to pull the rope down and then close the landing doors. It's a passive mechanical system. Passive. Now this is a guide roller. Okay, guide roller. So you can see this is the guide rail. This is guide rail, like an I-shaped guide rail. So three rollers, and this is a little bit different from train. For trains, you only have one roller, right? One wheel, one wheel on the rail, right? But for lift, because because the lift is moving vertically, so you need to make sure that the lift will not swing sideways, okay, sideward, and will not swing perpendicular to the landing door. Okay, so two-dimensional. It's a two-dimensional stabilization. For trains, okay, you just need one, just need one, okay. But for the lifts, you need three on one side and then three on another side. So usually you have two sides, and then you have two sets of guide rollers, one on top and one at the bottom. So actually, six guide rollers on one side and six guide rollers on another side. Okay. Okay. One question: landing door will close earlier than car door, and car door opens earlier than landing doors? No, they open at the same time. I told you before. There's no power to the landing doors, so the landing doors cannot be opened and closed automatically. So when the car reaches the landing, the mechanical linkage between the car doors and the landing doors are set up. Okay, and then when the car doors are open, landing doors are open automatically at the same time by the mechanical linkage. And when the car doors are closed, the landing doors are closed at the same time by the mechanical linkage, right? Okay, so you can see the guide roller here. So two sets of guide rollers, one top and one bottom on one side, and two sets of guide rollers on another side. Now this is the guide rollers at the bottom of the lift car, right? So when you visit the MTR station, okay, MTR station again, then take a look at the guide rollers, because the hoistway of the MTR stations, inside the MTR stations, bring passengers between different platforms. They are transparent. Okay, the hoistways are transparent. So the best way to take a look at the lift system is to go to MTR stations. They have transparent platforms, and you can go inside, and you can see the hoist ropes, the traveling cables, the governor ropes, and sometimes the buffer. Okay, the buffer. Car top as well. Okay, and this is a counterweight, and counterweight. They are strips. They are metal or concrete strips on counterweight, because they put counterweight one by one. Okay, suppose each strip is 5% of the total weight, then you need 20 strips. The counterweight is used to balance, okay, the force from the car. And remember, most of the time, counterweight is set at the weight equal to the weight of the empty car plus half the passenger weight, but not necessarily half. Sometimes 45%, or even down to 40%. But seldom beyond 50%. Okay, why? When we talk about traffic analysis, I'll tell you why. Why the counterweight usually set to 45%, not 50%. Okay, but 50% is the norm. And you can see the counterweight. Okay, strips. They are not one whole piece of metal or one whole piece of concrete. They are in strips. Okay, so that it's easy for you to weight it. Okay, 5%, 5%, 5%, and more and more. Now, overspeed governor. Now, overspeed governor is a very important safety-wise in a lift system. And I will show you the diagram of the safe overspeed governor. So you can see this is a sheath here, and then a rope, very thin rope laid on the overspeed governor, and then one side of the rope will go down to the top of the car, and then the other end of the rope will go down. We call the governor rope, 6 mm. Usually 6 mm rope is used. So the rope will go down to the bottom, the pit of the lift shaft, bottom of the shaft, where there's a tension pulley, and then around the tension pulley and go up again, and then attach it to the bottom of the car. Okay. So that means when the car is moving up and down, this overspeed governor shift also rotating, of course, in different direction. Okay. Suppose when the car is suppose this guy is the car, this side is the counterweight. Sorry. This side is this side is the car top, and this side is the to the tension pulley. Then when the car is going up, then the shift will rotate clockwise, and if the car is going down, the shift will rotate anti-clockwise. Right. Now the purpose of this shift is, you can see here, the fly weight. This is a fly weight. Okay. Now when the car is moving under rated speed, safe speed, okay, rated speed or the normal speed, nothing happens. But if the car is moving downward under very high speed, then this fly weight will, because of the centripetal force or centrifugal force, the fly weight will try to go outward. Okay, and it will trigger the mechanism. Then the rope will be trapped. Okay, trapped. And then once the rope is trapped, the safety gear will be activated. Then I'll show you later. Okay, when we talk about the safety gear. Now this is a safety gear. This is the tension pulley. Remember, the rope will go around the governor and then go down until it go down to the pit. This is the pit, the bottom of the lift shaft, and then go around the tension pulley. This is the tension pulley, and then go up again to the bottom, attach it to the bottom of the car. Right. So it's called tension pulley. What does it mean? It means that you want to provide tension to the rope. Otherwise, the rope will be loose. Okay. So you need to make sure it's always straight. So you need a tension pulley. Okay. This tension pulley tries to pull the rope downward. Okay. Tension pulley. Now this is a safety gear. Safety gear. Okay, the rope is used to activate the safety gears, and we'll have a more clearer diagram on the safety gear later. Safety gear is the last means of safety. Okay, so when all the ropes are broken, okay, the car falls down freely, then what can save you is the safety gear. Okay, car position detector, because the lift car control needs to know the instantaneous position, of the lift car. So every floor you need some sensors. Okay, so when the car go by the sensors, then through the cables to the controller, then the controller will know the exact position of the car, right? So every floor you need a car position detection. And then you can see here, that's just by the side of the feedback roller. This is a way to check position of the car. That's why after power failure, the controller will have no idea where the car is. Okay, so after power failure, and then the electric power restore back to normal, then the lift system will try to drive the car up or down. Okay, up or down, depending on the previous position of the car, up or down, and then when the car goes up and down, it will have detection again. Then the controller will know where the car is. Motor drive. We shall come back to this in more details later. Okay. Now, I just give you a brief concept. There are basically two types of drive. Motor drive for traction lift. Let's see traction here. Traction, you have the drive shift, and then on top of the drive shift, you have the grooves. Okay, V grooves, U grooves, with undercut, so 3 types. And then you have loops laid on the grooves. And then because there's a contact between the loop and the groove, so when the shift rotates by friction, the loops will be driven either clockwise or anti-clockwise. So it will lift the car up or let the car down. Okay, when the car is going down, you are lifting the other way up. Okay, so it's always lifting something. Either it lifts the car up or it lifts the counter way up. If you lift the counter way up, that is the car will go down. Right. Now this is called gearless, no gear. You can see no gear. Gearless means the rotating speed of the motor is the same as the rotating speed of the drive shift. That's gearless. This is geared. This is more old-fashioned. Okay, but not really old-fashioned. Nowadays, quite a number of modern drives are geared. Okay, geared as well. Geared means the rotating speed of the motor is not the same as the rotating speed of the drive shift. Right. Okay, now first we'll talk about the gear. The gear first. Sorry, no, gearless first. Gearless first. Now, gearless. This is the drive motor. This motor. This drive motor is mechanically connected to the drive shift through a brake. A brake. So this brake is how to say electrically released and mechanically applied. So that means if you want to release the brake, you pass a current. You pass a current through the brake, then the brake will be released. If you remove the current, no current, then the brake will be applied mechanically by springs. Okay, by springs. So when the motor wants to drive the lift car up or down, then you pass a current through the brake, then the brake is released, and the motor will start to rotate. Okay, rotates. Remember, the torque produced by the motor is the unbalance between the counterweight and the car. Okay, not the full weight of the car, just the unbalanced part. And then during emergency or when the car goes to a floor, then the motor stops operating and the brake is applied by removing the current. Okay, mechanically applied. And this we call it a fail-safe design. Fail-safe. That means fail-safe means even if it fails, it's safe. No power is fail. No power failure safe. Now, from here to here to here, you can find this in all gearless traction drive in nowadays. Now, but why you can see you see two more machines here. This in the old days. In the old days, how did you power or energize the motor? It's by generator. This is a DC generator. This is a DC motor. So but this DC generator has no mechanical power. You need for a generator, you need a mechanical power to drive it. You call it a prime mover, right? Prime mover. Then you need another motor. So you have a three-phase AC motor. AC motor driving a generator. Then the generator will provide power to this DC motor. Why you need to use DC motor? Because for gearless gearless lift, we want a high speed. Usually in the past, gearless lift were for high speed lift, and then low speed lift is geared. Okay, geared. Gear means you step down the motor speed. Step down motor speed. That means lower speed. So in the past, how could you control the DC motor? Is by varying the voltage applied to the motor. Okay, and you need a induction motor, three-phase motor driving the DC generator. Okay, and then by driving the DC generator, you generate voltage to control the DC motor. Right, and nowadays we don't have this anymore. It's for MG set, motor generator set. No MG set anymore nowadays. So you use power electronic drive directly, energizing the motor. Okay, and we'll talk about that towards the end of the course. Now, for lower speed lift, you have a gear. This is a gearbox. We call it a worm gear. Worm gear. The distinctive feature of worm gear is that the driving shaft is perpendicular to the output. The input shaft is perpendicular to the output shaft. Okay, so there's a braking function within. Okay, braking function within. But having said that, it depends on the structure of the gear inside. Not all worm gears have braking function. It depends on the angle. Okay, on the angle between the gear. Okay, the gear wheels. Now, for this one, you have the brake. The same. We call it the horseshoe. Horseshoe. It's like a shoes of the horse. Okay, horseshoe brake. We want to release the brake to apply current to the brake. It will be released. You remove the current, the brake will be applied. Then you have a motor. Okay, AC motor, and then this AC motor drive the worm gear through the brake. So if you want to stop the lift, then you apply the brake. Then the driving input shaft will be braked, and then the output shaft will also be braked. And the output shaft will break the sheath, and the sheath will apply friction on the ropes and break the lift. Okay, so this is so for since you have the worm gear is usually step down. That means the speed of the input shaft is higher than the speed of the output shaft. Right, so that's for lower speed lift. Okay, and you learned the machines theory before. When the speed is reduced, the force is increased. Right, force is increased because speed times force is power. Right, for motor, speed times torque is power. Okay, torque is force. Same. So by reducing the speed, you can increase the torque, increase the force. All right. So we talk about traction lift, we talk about hydraulic lift, and then for drive, we have different types of drive. We just talked about this one, DC Watt-Lear nut. It's MG set, motor generator set. Okay, Watt-Lear nut is a name of the inventor. It's a DC motor. This is a DC motor. This one is a DC motor. In the past, not now. Now it's AC. So DC Watt-Lear nut, and then this was common in the 60s or even 70s in the last century, and then by mid 70s or late 70s, we had power electronic. Varista nut is the power electronic. So power electronic means we don't have the motor and generator set no more, and you use power electronic to directly feed a controllable DC onto the DC motor. Okay, so no more motor and generator. And then we have AC motor. Now, for very more than half a century ago, this is a standard AC motor. Okay, AC, very slow, very low speed. Okay, it's called AC2. AC2 means there are two sets of windings on the motor, and we'll go back to this one later. Okay, AC2 means two sets of motors. One is slow speed winding, one is fast speed, high speed winding. Okay, so you energize different windings, then the motor speed will change. So it's called AC2, AC two speed. And then later we vary the voltage. Vary the voltage. It's called AC variable voltage. So it's called ACVV drive. And then by late 80s or mid 80s, late 70s, early 80s, we start to have AC VVF. Okay, VVF, variable voltage, variable frequency. Okay, so by mid 80s, we start to have AC, but not yet common. AC VVF starts to be very common by 90s. Okay, by 90s. In early 90s, we still got ACVV. And I remember in early 90s, I conducted a consultancy project for the housing department. And then I recommend that AC variable voltage are not energy efficient. Then from that report onwards, they don't buy ACVV anymore. So all housing projects are based on ACVVF. Okay, variable voltage and variable frequency. So nowadays we have many variations of ACVF. They're all VVF. Okay, so no matter what types of AC motors you are using today, they are VVF, variable voltage, variable frequency. Not this one is only variable voltage, no variable frequency, still 50 hertz. But there are many different types of VVF motors in nowadays, and we will talk about that during the last 3 lectures. Now this is a standard gearless drive. Standard gearless drive. You can see this is the brake. This is the brake, right? And then the motor. You can see the motor here. The motor here. The round motor, and then you have the brake here. And this is the brake. This is a brake arm. It's a brake arm. Okay, brake arm. So there's a solenoid here. You pass the current through the solenoid, the brake arm will be released, and you remove the current, then the brake arm will be applied by what? By the spring. You see the spring here, spring here. Okay. By removing the current from the solenoid, then the spring will apply the brake, apply the arms on the brake shift. This is a brake shift. This one is a brake shift, right? Brake shift. And then these are the drive shift, mechanically coupled together. Okay. And then there's no gearbox, so it's gearless. And then you can see the grooves here. The roofs laid on the grooves, right? And then when this sheath rotates by the motor here, the roofs will be rotated, moving. Okay. And you can see this is gearless, and this is geared. Okay, gear. It's easy to tell. The direction of movement of the drive shift is not the same as the direction of movement of the motor. Okay. The motor and then the brake, and then the worm gear down there, and then you have the shift, right? Major safety devices. Intercom is one, CCTV is another. So nowadays, all lifts are provided with CCTV. So in the management office, they can see what happens inside lift car. Intercom is the communication, verbal communication between passengers inside lift car and the management office or the machine room. Right? Actually, the signals go to the machine room first through the traveling cables, right? And then these signals will be further conveyed to the management office. Overrun switches. If the car goes up to the top floor, but it continues to go up, dangerous, right? Or the car goes down to the bottom floor and it continues to go down, dangerous. So we have overrun switches. So if the car goes beyond the top floor or the bottom floor, then switches will be activated to turn off the power. Okay, when you turn off the power, there's no power to the motor. Okay, no power to the motor, and at the same time, there's no power, so the brake is applied. Okay, no power, it gets applied. So it's safety. Landing door interlock. Okay, all landing doors for each landing, there are landing doors, right? The lift car can only move when all landing doors are closed and locked. That's the technical requirement. Okay, all landing doors must be closed and locked, okay, before the car can go. So there's a series. It's a series circuit. linking all the landing doors together. Okay, so only when all doors are locked and electrically proven, then the contact is closed. Then the whole series is short circuit, and the car can go. But remember, you have also got the car doors. The car doors, you also need an interlock. That means you need to mechanically lock the car door and electrically prove the locking condition of the car door. Right? Then again, series. So the circuit, the series circuit will go through all the landing doors and then back to the machine room, and then go down the traveling cables to the car, and then to the car door locks, and then back to future, and then go back to the traveling cable and back to the machine room. So this is the whole series of contacts. Okay, only when all these contacts are closed, the lift motor then start to be energized and the brake will be released. Right? Governor and safety gears. I told you before. I will talk about this in more details. Governor and safety gears. When all the ropes are broken, then the car will fall down, right? And governor will detect such falling speed and then activate the safety gears when the falling speed goes beyond dangerous level. Okay, usually it's about at least 110%, okay, of the rated speed. And then buffers I showed you before. When the lift car goes down, and then it passes the bottom floor, it continues to go down, and even the limit switches, the overrun switches cannot stop the car. Then the buffers will stop the car, or the counterweight. When the counterweight goes down, that means the car goes up. When the counterweight goes down until the car passes the top floor, it continues to go up. That means the counterweight continues to go down, and the counterweight will be stopped by the buffer, right? The counterweight buffer. Now there are two types of buffer. This one is called spring buffer. You can see the spring here. Okay, that means if the car fall down and then hit the spring will stop the falling speed of the motor. Right? This is spring. Okay, when the car press on the spring will have a resistance on the car. Okay, and then how much the spring can be compressed is called a stroke of the spring. Okay? And that is the maximum distance moved by the car until it stops. Okay, until the car stops. And this is a spring buffer. Another type of buffer is the oil buffer. This is the oil buffer. When the car hits the buffer, there's a reaction in the oil buffer. Okay, and it will stop the car as well. Now, oil buffer is for high speed lift. Spring buffer is for low speed lift. And they have a technical term. This one is called energy accumulation buffer. Energy accumulation. Spring buffer is called energy accumulation. Why? Because when the moving car hits the buffer, compress the buffer, the kinetic energy from the lift car is actually stored inside the spring as elastic energy, right? Elastic energy. So energy is accumulated. It's not dissipated. But for oil, when the car hits the oil buffer, the buffer will go into the oil, and the oil will dissipate energy. So that's why it's called energy dissipation type. And this is for high speed car, and this is for low speed car. So you can see here for spring buffer, normally the rated speed is 1 meter per second, at most up to 1.6 meter per second. But for high speed, 1.6, 2, 2.5, 3, or more. Okay, you have oil buffer. Okay. Now the stroke, there are regulations in the design code on the stroke of the buffers. Okay, and you can see we have two types of buffer: energy accumulation, the spring buffer, and oil buffer, energy dissipation. Okay, so for the rule, the stroke of the spring buffer shall be at least equal to twice, at least equal to, not exactly equal to, at least equal to, okay, twice the gravity stopping distance, corresponding to 115% of the rated speed. Okay, now how to find the gravity stopping distance? Remember the formula: V square over 2g, right? V square over 2g. V square over 2g is the gravity storming distance. That is the when an object is falling down under a speed v, and then it's being braked with an deceleration rate equal to the gravity deceleration, 9.8 meter per second square. Okay, then the distance traveled will be v square over 2g, right? So v square over 2g, but v is 1.15. This v is rate of speed, so 1.15 v square. Okay, and then divided by 2g, but twice, so times 2 again. Okay, then you get 0.135 v square. Okay, and not less than 65 under all conditions. And then for oil buffer is more effective, so the stroke can be shorter, so it's equal to gravity storming distance only, so v square over 2g, just 1.15 v square divided by 2g. Okay, because the energy dissipation buffer is more effective in stopping the car. Okay? So how to get 0.135 is 1.15 v square divided by 2g and then times 2. For oil buffer, it's half of this one, because it's two times, and there's no 2 times, there's 0.0764. Now, if there's a electronic slow down packing device system, the stroke can be even reduced more. Okay, so 50%, okay, or even 33%. Now, this is a special. Usually, they will stick to this value. Okay? Now, this is the mathematical model of energy accumulation buffer. Okay, this is the relationship between the force on the spring. Actually, this is not a spring; it's a piece of rubber. Okay, it's a piece of rubber. Okay, so for spring, F equals Cx, right? Because remember the Hooke's law, the force on the spring equals to the compression, constant times the compression. For a buffer, then you have the power n. Okay, n may be equal to 1 for real spring, right? So F is the reaction force, and C is the stiffness, the Hooke's constant for spring, and the X is the compression. Okay. Now, the mechanical force acting along X, okay, onto the buffer, okay, is dissipated, okay, dissipated by the formula force times distance, and then from integrating from 0 to X. This is the energy dissipated, or not dissipated, stored, not stored by the buffer, okay, and this energy should be equal to the loss in mechanical kinetic energy. So V naught is the original speed when the car is hitting the buffer, okay? And then V is the instantaneous speed when the buffer is compressed to a distance x, okay, from the beginning. So this one is the loss in mechanical kinetic energy. And this one is the loss in potential energy, mgx, potential energy, okay? Then you do, x is the compression of the spring, and you do integration. And remember, where at the moment when the car hits the buffer, V equals to V naught. Okay, so V equals to V naught when X equals to X1. X1 is the initial point of contact, and this is 0. Okay, 0. And then you get all the constants, right? Then you can calculate 3, and you find that this curve looks like this one. Okay, and you can find 3 and 2. So 3 means you just put V equals V naught square, then you'll get X. Okay, the X equal to 0, or X, there's another solution, and this equal to this one. Okay, and to find 0.2, you just differentiate this equation. Okay, and you get dV dx equal to 0, then you get X2. Okay, and this is the point where the speed is maximum. So what you expect is the moment when the car hits the buffer, it continues to accelerate due to the gravity, but the force exerted on the lift car gets higher and higher as x becomes larger and larger, right? So at a point two, the maximum speed is reached, and then from that one onward, the car starts to decelerate, okay, until decelerate back to V naught original speed, and then finally get to zero. Okay, the zero speed. And that can be plotted by this formula, right? And then for a retardation, you use the VDX and then put X3 there, and you get this. You can derive yourself, okay? See whether I made any mistake. And this is energy accumulation. So remember, the energy stored inside the spring or the buffer is equal to the loss in kinetic energy and loss in the potential energy, right? Now, the oil buffer is more commonly used, okay? Is more commonly used. The principle is in this way. You have inner cylinder and outer cylinder. This is outer cylinder, okay? So what you saw here is outer cylinder. This is outer cylinder, okay? But inside you have an inner cylinder. You have an inner cylinder here, and then the buffer, the piston here is attached to the inner cylinder. So you see, it's the inner cylinder. Okay, and then so that's why when the car hits the piston, it will this piston will press on the oil inside, and this oil will be squeezed outside. So you have holes here, a lot of holes here, small holes on the inner cylinder. So the oil will be squeezed outside the inner cylinder into the outer cylinder. Right? Now then, because the oil is being squeezed out, okay, from the inner cylinder, a force will be built up to resist the further movement of the piston. And remember, the pressure built up here times the area of the piston is equal to the upward force. Okay, and this force is used to slow down the car, right? And so this is the equation, okay, to find out the relationship between the stroke and the speed. Okay, the speed. So at the moment when the car just hit the piston, the speed is highest, and then you will gradually die down until it stops. Okay. Now then, how to find out the mathematical model of this oil buffer? So first of all, you have this equation. Okay, velocity of piston V times the area. Okay, piston area. Okay, now the V times SP is actually equal to the amount of oil being squeezed out of the inner cylinder. Okay, because V is the velocity of piston going downward. Okay, it's the velocity of this piston going downward. This is the same as the speed of the car. Okay, same as speed of the car. And then V times the area of this one, that is the amount of oil being squeezed out per second. And this is equal to the discharge velocity of the oil times the area of escape holes. Area of escape holes is the area here, not areas above here, areas down below, because only oil below the piston will be squeezed out. Okay, so it's equal to the discharge velocity times the area of the escape holes and the discharge coefficient. Okay, this formula is important. Now, then the discharge velocity. What is the discharge velocity? That means what is the velocity of oil being discharged here? Is pressure dependent, right? Pressure dependent. And remember, half rho v square. Half rho v square equals pressure. Okay, that is the Bernoulli's theorem, right? So you know the pressure of the oil, and you know the rho. Rho is the density. Okay, so here is gamma. So half gamma v square is equal to pressure. So the speed is equals to, because half gamma v square equal pressure, the speed will be 2 times pressure divided by gamma, take the square root. Go back to the Bernoulli's formula that you learned in year 1, okay? Basic fluid mechanics, right? And so pressure is equal to what is pressure? Pressure you get from here, okay? From this one. You have V, then V, then you have pressure. You know, you relate this formula and this formula together. Then you have the pressure, pressure related to the speed. Okay, and speed, force on the R is equal to pressure times area of the piston. Okay, so this is equal to this one. Now, since for gravity stop, again, the distance equals to v squared over 2g. Then you have v equals to root 2gy. That means you expect that the car will be decelerated under the gravitational constant, 9.8 part divided by 9.8 meter per second cube. Right? Then you have if this equation, finally this equation. Okay. So by having this equation, then you find that you need a constant force to constantly decelerate the car. Y must be proportional to Qy squared. Okay. So what is Qy squared? Qy is the area of hose. Qy, area of the hose below the piston. Y is the stroke. Y is the stroke here. Okay, stroke here. That is this is the distance. Okay, that means in order to have a constant force acting backward to stop the car under a constant force under gravitational deceleration, you need the distance here proportional to the square of the area of hose here. Okay, and that's what you need to design your inner cylinder, right? And this is a curve. Okay, the curve giving you the relationship between the total stroke, the y, and also the distribution of hose. Okay, so this what's important is this relationship. All these are constant. SP is the area of the pieces constant. Gamma is the density of oil constant. G is constant. Mu is a coefficient. It's also constant. Okay, so y over Qy squared must be constant. Okay. Now then F equals to P times the area of the piston, right? Pressure times area is equal to force, and this is the force you expect. Okay, force you expect. And so the initial retarding force only depends on the speed of impact. V naught. That is the moment when the car hits the buffer. Okay, that's initial retarding force. Okay, and this initial retarding force is not dependent on the car load. So if the car is heavier, then it takes longer time to stop. If the car is less heavy, then it takes less time to stop, right? So what is the exact force you need to react? Okay, the retarding force is equal to Q plus K. What's Q? Q is the load inside the car. So suppose it's full loaded 1,000 kilogram, then Q is 1,000 kilogram. K is the weight of the car, empty car. So let's say 2,000. So 3,000 kilogram here. G is the gravity constant. A is the deceleration. And now remember, we hope that the deceleration is the same as the gravitation. That means we want the car to decelerate under 9.8 meters per second square. So that's why you have 2g. A is equal to g. So 2 times g times Q plus K. And this is the force. This is the force you require to stop the car from descending. Okay, under a deceleration of. Okay, now why g? Because according to the standards, whenever a car is braked, okay, by safety gear, by buffer, or by brake, okay, whenever the car is being braked, okay, the deceleration rate must not go beyond g. Okay, must not go beyond g, because when the car is braked, is descending. Oh, sorry. When the speed is decelerated. When the car is decelerated, your feet is on the car. So first of all, under rated speed, you feel your weight on your is it what is it called? What's I can't remember. Is it palm or something like that? Okay, bottom of your foot. So you feel your weight equals to your own weight. Okay, on the car. Yes, the normal reaction, right? So you feel your weight on the foot, on the 2 feet, right? But when it's decelerated, you feel more, right? You feel more. So if the deceleration rate is too high, then you cannot stand yourself. Your feet you cannot stand yourself. Then you fall down, fall to the floor of the fall down to the floor of the lift. Very dangerous, right? You drop down, you fall down. So it's very dangerous. So that's why the regulations say, under all circumstances, whenever the car is being braked, either by the brake or by the safety gear or by the buffers, the deceleration must not go beyond you. Okay, that means your feet should only need to stand 2 times your weight, 2 times your weight. Okay, but this is a very short period of time. Only we are talking about a couple of seconds. Okay, a couple of seconds only. So your feet must be able to, yeah, the normal reaction. Thank you for giving this name. The normal reaction should not go beyond 2 times your weight. The smaller is better. Okay, but if this if the deceleration is too small, it takes too long. It's not. Okay, so that's why usually they're talking about 0.2 G and G. That means when the safe gear or the brake or the counterweight decelerates the car, the deceleration rate should not go beyond G. This should not be too small. Okay, usually 0.2 G. So maybe 0.5 G or 0.6 G will be good enough. Okay, that means under this situation, your feet can stand your weight plus your deceleration. Right? I hope you understand what I'm talking about. Right? Um. Okay. So before the end of this lecture, maybe I'll talk about this very important formula for fraction, and it's called the Euler's formula. Okay. Now I will derive this when we talk about ropes next lecture. Okay. Now, remember this: the sheath, your friction on the sheath. Okay, friction on the sheath, and the ropes are on the sheath, on the grooves of the sheath. Okay, you sum up all the tensions of the ropes together, and you treat it as one rope. Actually, there's not one rope. There are many ropes, 6 ropes or 4 ropes, 6 ropes or whatever. Okay, minimum is 3. I think in Hong Kong, minimum is 3 or 2 or 3. I can't remember, but usually 4. 4 is the minimum, and then up to 8. So you treat all 8 ropes as one rope. It's one rope, right? So you have 2 tensions, S1 and S2. Now suppose this one is S1 is down to the car, and S2 is down to the counterweight. And suppose it's full load, okay, full load. That means this side is heavier and this side is lighter. So the shift rotate wise, okay? The shift rotates clockwise to lift up the car, Now then, according to this Euler's formula, the tension this one over tension of S1 over S2 must not be more than E to the power F angle of wrap. You know, is it psi or phi, something like that. Okay, I don't know how to pronounce this Greek character alphabet. Now, this angle is called the angle of wrap. What's the angle of wrap? That is the angle of contact between the ropes and the grooves. Okay, so the rope start to be in contact with the groove here, point A, and then go around the sheath until it gets to point B. Now remember, point A and point B on the sheath or on the ropes keep on changing because the sheath is rotating, okay, clockwise, rotating, but the angle is constant. Okay, always the same. Okay, so F is the equivalent coefficient of friction, and I'll teach you how to calculate the equivalent coefficient of friction. Now, F is different from the coefficient of friction that you learn in your physics. For the traditional coefficient of friction, you're talking about a horizontal flat plane and then a block moving on the plane on the platform. Okay, and that's between metal and metal. Okay, so it's only dependent on the type of material that you're talking about. But for equivalent coefficient of friction, not only depending on the materials of the roofs and the material of the groove, but also depending on the geometry. Remember, there are different types of groove: V groove, U groove, and U groove with undercut. And I'll go into details next lecture. Okay, so for different geometry, the F will be different. Even though you have the same mu, the same coefficient of friction, they are all still ropes are steel. Ropes are made of steel. Sheath is made of steel, although they are of different hardness of steel. The groove is usually harder than sorry, the ropes are usually harder than the groove, okay, of the sheath. So they're all steel. They're all steel, different types of steel. So the coefficient of friction between steel and steel, mu, okay, is not used. We use F here because F includes not only mu but also the geometry, right? And then so you can see higher the contact or angle of contact, the higher the ratio, and higher the ratio. Okay, so you can see if small S2 can provide a big S1, that would be good. Yeah. So that's why if S2 becomes 0, the sheath is functionless. Okay, it cannot rotate, it cannot lift the car anymore because when S2 is very small, S1 has to be very small. It cannot be large, right? So and that is the beauty of the traction sheath. It gives you a lever. Okay, by a smaller S, you have a bigger S. A small S2, you can have a bigger S1, and it depends on the angle of wrap and also the equivalent coefficient of friction. But F is constant. Okay, then the actual difference in the two tensions will be on the angle of wrap, and that is why remember I talked about the bull wrap. Okay, bull wrap machine. Bull machine means you increase the angle of wrap. Okay, by letting the loops go around here, we have the first angle of wrap, and then go to the diameter pulley and come back again here, and then go around and then go down to the counterweight. That's why you can increase the angle of wrap. By increasing the angle of wrap, then the ratio between S1 and S2 can be higher. That means a smaller S2 can provide a bigger S1. Now, this is a very, very, very important of a formula, okay, in traction. Okay, so whenever we talk about traction elevators, we need to use this formula. And next week, I mean, 2 weeks later, I will teach you how to derive this formula and how to use this formula. It's very important, right? Okay, I think that's all for today. A little bit slow because it's a introductory concept to the structure of a lift system. So and I will speed up from next lecture onward. So wish you a happy Chinese New Year, and then see you all on I think it's February 11th, 2 weeks from now, right? 2 weeks from now. Is it 2 weeks from now? Not 2 weeks from now. 3 weeks from now. Sorry, 3 weeks from now. Because the next week will be holiday, and then week after next will also be holiday, Chinese New Year holiday, and then week after next. So it's 3 weeks, 3 weeks from now. All right. So happy Chinese New Year, and then enjoy, and then we come back, and I will speed up a little bit. That's the first one. The first lecture, I need to make sure that you understand the structure of a lift, because when in the future we are talking about the components, okay, components of the lift system. Okay, so any immediate question? If no problem, then you can ask me questions later, or you can write to me to my email address or Mr. Liu, and then I can answer. Okay. Okay. Thank you. Good. Good night. Bye bye. Bye bye.